From Good to Outstanding challenged good teachers to become even better. Now top inspector Claire Gillies is back, revisiting some of the teachers she saw last time. She'll observe them once again to see if they've moved on in their teaching. So will they deliver an outstanding lesson?
With all these teachers I've come back to see again, although they may not have all been seen delivering an outstanding lesson, it's clear they've all got a better insight into what makes an outstanding lesson, an outstanding learning.
In the series From Good to Outstanding, we challenge teachers from reception through to Key Stage 4 to go from good to outstanding. Top Inspector Claire Gillies observed them teach. We gave them one-to-one expert advice in their subject areas. And a few weeks later, Claire went back to see whether they'd upped their teaching from good to outstanding. In this programme, Claire will revisit secondary maths teacher Simon Brilliant.
I'm actually looking forward to Claire coming back. I think I've improved from when she saw me last time. In fact, I'm absolutely confident I'm going to show a much better lesson than I did previously when she came.
Simon teaches maths at Hornsey School for Girls. When he was first filmed, he was in his second year of teaching. Now, 3 years later, Simon reflects on how taking part in the programme has influenced his teaching.
Right, girls, can you get yourself a mini whiteboard and write the next two numbers in these three sequences?
I think looking back on where I was those years ago, it's obvious that I'm doing almost the standard things that new teachers do, which is trying to fit too much into a lesson. And I think as time's got on, it should be about students learning themselves, and I should just be trying to facilitate and pushing them in the right direction, but not actually necessarily giving them all the answers.
When Claire Gillies first observed Simon in the summer of 2006, he was teaching patterns and sequences to his Year 7 class.
This is the term-to-term rule. What we're going to work out today is now the position-to-term rule. I've simply written the same thing, it's a mapping diagram, but I've now written it across the board.
Obviously, the one thing I looked at myself and went, oh my God, I'm talking far too much. I talked for almost half the lesson.
So I want you to draw tables like this.
Back then, Simon's lack of clarity with his instructions was also an issue.
Do not draw the mapping like they've got here. Imagine it's turned sideways. So draw it like this, not like this. Is that clear what you need to do?
Do it like this, not like that. Just like this. Turn it round, stand on one leg, put your hand on your head. I mean, how many more instructions can I give them to make it even more confusing? And I've tried consciously. I'm aware every now and then I'm doing that. I'm still, even now, going, I'm talking at them too much, blah, blah, blah.
Claire suggested that Simon engage a lot more with his pupils and give his maths some real-world context.
Perhaps we needed to be a bit more practical in several elements of the lesson. A touch of help with the realism, and that just might give them that little sparkle that perhaps was missing in the whole.
I think the first thing that Claire said to me was where's the realism in this? Why are we doing this? And I'm trying every now and then to come up with real-world examples about why are we doing this? What is the point of doing this particular piece of maths?
To boost Simon's teaching, he had an intensive day of bespoke CPD. Principal mathematics lecturer Alison Clark-Wilson was brought in to offer expert advice.
What I'd like you to do to start with is pick out, say, 2 or 3 that you saw going on in that lesson.
Okay, well that's a really obvious one.
So looking for patterns.
Yeah, definitely doing that.
Yes.
I was going to say showing interest and motivation, but I'm not sure if they did show an interest and motivation. I've got a feeling that perhaps they might have showed interest, but I'm not sure the motivation was being there.
Claire and Alison both said, why don't you make lessons more fun? And that's the one thing that I've been, since I was filmed, I was trying to say, how can we make this more fun for everybody?
These are very stimulating, and I think
Alison showed Simon a range of resources to help him engage his pupils more.
You don't think perhaps that they might find this a little bit childish.
You've got to give the rationale. It's unlikely a science teacher will take the science equipment away because they can't learn science without it. Well, some of us would argue that we need these resources to learn maths, that they actually support that conceptual development.
I've certainly taken from what Alison said, the whole thing of just because you've got numbers there doesn't mean it's going to be interesting, and giving the students something to play with.
Back then, Simon had just 2 weeks to take all the advice on board and try it out in the classroom.
This person started with a bar of chocolate, they're absolutely ravenous, and they've just gone...
When it came to the crunch and Claire returned to observe Simon for a second time, there was some good news.
I mean, there was much more a feeling of enjoyment in the whole lesson. I felt they were sort of more with you.
And some bad news.
Have we at any stage talked about why we're interested in straight lines on Y and X axes?
I don't believe we have.
That was the one question that Claire asked me, which completely stumped me, which is, have we at any point explained why we're doing this? And I just sat there going, I have no idea. The reason is we're doing maths. That's surely reason enough. And I think it's at that point, looking back, I was going, yeah, you need to give them some kind of context.
Despite all the expert advice and Simon's hard work, Claire did not give his lesson an outstanding that time. So now, with 3 more years teaching under his belt, Simon is preparing for Claire's return.
Books out, we're going to do reflection in a coordinate grid. I need 2 volunteers who can be a human mirror.
Before Claire comes to observe him, he's asked his head of department, David Kaplan, to give him some critical feedback.
Since the first film was shown, he has improved in his teaching enormously. He's gained in confidence, I think. He's gained in versatility in the different techniques that he uses to teach.
Whatever Helen does, Zara, you have to copy. So that's super. So we get how mirrors work.
The one thing I picked up from the previous time of filming was almost being told or being allowed to do something different.
Since we are as bright as buttons, this is going to take 5 minutes, isn't it? I've got a shape A and I've reflected it in some hidden mirror lines. Can you draw in those hidden mirror lines, please?
There's one there. This one. There's only 3. There's one there. How do you find this one? How many is there? Wait.
Before, it was, again, all about me, all about presenting it at the front. And nowadays, what I'm trying to do is at the very least, get them to work in pairs.
Students were very focused on the work they were doing, and they wanted to get something out of that lesson.
If I take any point and I reflect it in the line y equals 0, what happens to the coordinates then? If I reflect it in the line y equals 0, what happens to the x coordinate?
It goes minus.
Sorry?
The main issue for Simon is his questioning of students. He finds it very easy, because he is a bit of a showman, to slip into the mode of asking questions to the whole class.
What's this last one going to be then?
X doesn't. No. 2.
X doesn't change, yeah? So the second part must be?
2 minus y.
We're geniuses! Hey!
I think I know that my lessons are getting more connected with the students because they themselves appear to be enjoying them more. When they're leaving with sort of a bit of a spring in their step.
Right. And the rest of you, thanks girls. See you Monday. Yeah.
I think it was a lovely lesson. You know, you could tell just from looking at the kids and engaging with them that they were enjoying it, that they were getting a lot out of the lesson. There are a few whole class interactions, and I know it's the way that you like to work, and it's a good way of working, is questioning the whole class and seeing what answers come out. But it does miss out, you know, a significant proportion of the students getting involved, and you're unsure as a teacher whether they're keeping pace, whether they're keeping up with the discussion, or whether they're just hanging back on the sidelines listening, or whether they don't get it. If he's able to incorporate the questioning, which does force students to think, the deeper questioning, then he will move forward.
3 years ago, Simon was also struggling with his time management and his planning, displaying a rather relaxed attitude.
Loads of things are going to go wrong. I mean, they're going to be bouncing. They're going to be absolutely bouncing for the first 10 minutes.
If you can foresee all these problems, that's why it's more important to plan for them
Nowadays, Simon is putting more effort into his planning.
I'm going to get them to work in pairs, which works better because then I can go around and listen to them talking to each other, and it makes it much clearer about whether they understand. And also, we're going to get them using sort of football cards. These should be green, but I didn't have enough green, so we'll have to be blue instead.
It's the day of Simon's observation. Claire's back. After 3 years of working hard on his teaching, will Simon impress Claire enough to get outstanding?
We're going to do tessellations today. Recognise which quadrilaterals will tessellate across a plane and know which regular polygons.
Simon is teaching a 60-minute lesson on tessellation.
What is a tessellation? Or a tessellation across a plane? Talk to the person next to you and then tell me in 15 seconds.
You meant tessellation as a word before. When I first saw Simon, it was definitely the lesson planning that let him down, the lack of group work, lack of relevance. Why are we studying this particular aspect of mathematics? He clearly had made some progress between the first and second lessons. The point is, in the last 2+ years, has he kept moving forward with the quality of his teaching?
Natasha, anyone on your table, do we know what a tessellation is?
It's a shape that can be like, it fits together over a page, like you can repeat it over and over again.
Repeat it over and over again, yeah?
Same shape.
The same shape that covers the plane, a space, without leaving any
gaps.
Absolutely. Can you come up with an example of where you see tessellations every single day?
The bathroom, the board.
Yeah, the bathroom.
The bathroom. What, you mean like that?
Yeah.
I went round and I've been designing some bathroom tiles in pairs or threes if you're on your own. Can you tick, cross or question mark on these shapes? Which ones make good bathroom tiles, which ones do not tessellate? Which ones tessellate, which ones do not tessellate?
That heart can, but this heart can't. I'm gonna. But this can't either because if you think about the quiver on the thing, it wouldn't match.
This
But then think about the quiver on the bathroom.
that can. Yeah, that.
Right, you've got on your desks little cards, yeah? So if you think it tessellates, you can hold the blue one up. If you think it definitely doesn't, you hold the red one up. And if you're not sure, you can hold the yellow one up. So, does this tessellate? Come on, quick. Blue is yes. OK, fine. This one? OK, this one? We're not so sure about this one. It doesn't? OK. What about this one then?
No, it doesn't.
You say it again, Aisha?
You can flip it over and it'll fit in on the next bit.
OK, we'll look into that. I've got a collection of shapes here. So what I want you to do is take each of these envelopes, take the shapes out of them, and see if you can put them together and tessellate them.
Yay! What's meant to make like a square shape?
That doesn't tessellate.
OK, I like the way you've got these two together, that's good.
These four go together then, yeah?
But maybe it might have to go this way.
So you think those stay?
We've done it. They could, but I don't know.
So those definitely
These can,
tessellate,
sir.
yeah?
Yes.
OK, so you can tick, put them back, tick yes, get on the next one.
No, there was one more.
Not very well, but does that actually tessellate?
Yeah.
Which shapes were easy to tessellate? Which ones were really... Triangles. Why are triangles easy to tessellate? Do you want to come up and show us how you tessellated those ones? And through the magic that is computers, we're happy triangles tessellate, yeah? Vaguely, sort of. What's the really tricky shape? It's a quadrilateral with no right angles, no parallel sides, all the sides are different length.
Oh, we did that one, yeah, that was hard.
It's hard. Do you think it tessellates?
No.
If I put them all the same way around and then just put them so corners go to corners.
And then
And then I should be able to take one in the middle and...
it does go. But
Does it?
Ugly. It does look
Oh,
ugly.
did I say it had to look pretty? Let's pick one of the points where these shapes meet. How about here?
Yeah.
A plus B plus C plus D adds up to...
360.
Which means there can't be a gap there, can there?
Yeah. Oh, that's
Here.
a smart way of checking.
Isn't it?
It actually is.
So, what can you tell me about quadrilaterals?
They always tessellate.
Always. OK, I want you to do the same with each of these regular polygons. Work out the number of sides the size of the interior angle, and then tell me if it tessellates or not. Is that the interior angle, or is that the exterior angle?
Interior.
Is it?
Yeah.
How do we work out the interior angle?
Because it has 5 sides, you have to divide 360.
But that gives you the exterior angle, doesn't it? Remember? When I worked out what y was the exterior angle. The interior angle is...
Wait, the exterior angle take away... What's
Take
it?
away from 180.
Yeah.
Yeah. You should have got this. I think some of you haven't quite got all of them. Back to this question then. Let's finish this off. Why do we always use rectangles then?
Because they tessellate.
It's the simplest one to do, isn't it?
Yeah.
Squares are too.
Squares are. Do we use squares?
I have square tiles in my
We do sometimes, yeah. OK. God, got there in the end. Blimey.
So, how does Claire rate Simon now?
Simon, it was a real treat to come back and see you teach again after sort of, well, over 2 years. And certainly I thought that was by far the best lesson I've seen you teach. I enjoyed it so much. The students certainly enjoyed it. It was a wonderful atmosphere throughout. And I think overall it was very convincingly good, and there were just 2 sort of fairly important and a few little minor things that just didn't tip it up into the outstanding. But my gosh, it was, you know, really special. And I'd like to sort of highlight, before I give you a chance to speak, the things I thought were so evident. Really good planning for enjoyment. And you made a comment the first time I saw you teach when you said, I realise now you've got to, it's an effort to plan so that the enjoyment just flows naturally. Well, that was there in bucket loads. It was great. There was more group work, which was something you weren't quite so keen on. And they sort of worked in pairs, they worked in tables, and they really shared ideas. And concentration, I mean, you could have heard a pin drop at some moments in that lesson. Resources, great, fabulous use of the interactive whiteboard. You were really trying to assess as you went along, you know, get a feel for who'd got it. And if you, before I say the sort of elements that just didn't quite come off, what would they be for you?
Yeah, I mean, the bit that I think I was aware of was them trying to get the idea between interior and exterior angles.
You got it.
And as I was going around, I was thinking, I should have spent another minute explaining this, or even drawn a diagram, and maybe even at the beginning done it as a starter.
Absolutely right. So that's the one little step of clarity that wasn't there for them, though you leapt in and sorted it out. And maybe the other step that needs to be thought about is the fact that, as you said before the lesson started, despite being one of the higher sets, quite a range of ability and quite a range of speed of working. Because one of the things that certainly inspectors are focusing on a lot is the teacher knowing the pupil's abilities and being sure that when you can prepare work for students of slightly different abilities, so you can slip it in so that they can all, in a sense, be moving forward at the same speed. You know, you're definitely heading for outstanding, and I really enjoyed that lesson so much. Thank you.
Thanks. It's very satisfying having someone of Claire's experience and knowledge and expertise to come in and see my lesson and, you know, reassure me in many ways that I am a good teacher, a very good teacher, and with a few little tweaks, I could be an outstanding teacher. And I'm very proud actually of what I did for her and what I showed her today. I think it's, you know, it shows that I have made a great deal of progress in the last few years.